Let's start with the interaction diagrams. Interaction diagrams include several different types of diagrams. For example, sequence diagrams, interaction overview diagram, communication diagram, and timing diagrams. So we are going to start from sequence diagram. I'm expecting that you are already familiar with sequence diagrams. But I'll try to discuss some advanced concepts. Sequence diagram is the most common kind of interaction diagram, which focuses on the message interaction between number of lifelines. So in sequence diagram, there is the concept of lifeline. Sequence diagram describes an interaction by focusing on sequence of messages. So there is a concept of message and there is a concept of sequence of message that are exchanged along with their corresponding occurrence specification of lifelines. The following nodes and edges are typically drawn in real-time sequence diagram. So these are some of the concepts we find in sequence diagram: lifeline, execution specification, message, combined fragment, interaction use, state invariant, continuation, destruction, occurrence, etc. Let's see an example. This is a sequence diagram. So first of all, let's see the lifelines. Here you can see lifeline. So comment is a lifeline. AWR sublet is a lifeline. Window is a lifeline. So how many lifelines are there in this sequence diagram? We find that there are 4 lifelines. This is Windows lifeline, commands lifeline, proxy lifeline, and DVR sublet by lifeline. Generally, the concept of lifeline is related to the object, when object is created and when object is destroyed. For example, for these 3 objects, we are assuming that before creation of sequence diagram, these objects were already existing. On the other hand, this object is being created at this point in time. Also note that time moves from top to bottom. So it means that the message which is at the top, for example, validate message, it is the first most message. And this message, which is a return message, is the last message. So time moves from top to bottom. Now this is a gate. It means that this is a point from where the sequence diagram initiates. Okay, and it goes off to some message enters into the sequence diagram, and then from here sequence diagram starts. So validate message is sent to Windows object. As a result, Windows object sends validate message to comments. As a result, create message, a proxy object is created. And later on, Ajax message is sent, which is an asynchronous message that is sent to the proxy object. So first object is created and then message is sent to this object. As a result, Ajax message is sent to DVR sublet object. Now, after sending this message, error is returned. As a result of this error, callback message is sent to Windows, and as a result, message is sent to back out of sequence diagram. This box, which is overlapping the lifeline, it is called execution specification. Then the point from where message is initiated, it is some particular point. That point is called occurrence specification. You can see the symbol of synchronous message is this one, dotted filled rectangle, and symbol for asynchronous message is simple arrow, which is not filled. Similarly, this is symbol for create message. You can say it's a object creation message. And this return symbol dash line, it is generally called return message. It is return message, this is return message. Here you can see an interaction diagram has been embedded here, and it is been shown as a black box. It has been developed or modeled somewhere else, and it is being used over here. That's why reference keyword is being used, and because it is using an interaction which has been modeled somewhere else, we call it interaction use. Let's see sequence diagram in action. Here you can see that there is a tool to reverse engineer class diagram. The name of tool is Object 8. In this tool, the class diagram creation is free, whereas once you download this tool, you will get a free license for sequence diagram creation for 1 month. So let's see the example. There is Java. There is Java interface, and there are 3 classes: circle, square, and rectangle, which are implementing the shape interface. Shape interface has an abstract draw method which has to be implemented by circle, square, and rectangle class. This structure is then used by this sequence diagram demo, which has a main method, and the implementation of behavior have been written in the main method. Let's see the code, Java code. This we are defining shape interface with the abstract void draw method. Then circle is implementing shape interface with the implementation of draw. Print line circle dot drawn. Then rectangle implements shape, and drawn implementation is rectangle drawn. And then square implementing shape, and its draw implementation is print line square draw. And this is the main method implementation. In main method implementation, you can see, first of all, the object of circle class is created, and then circle draw method is called, or we can say in the language of sequence diagram that circle object which has been created here has been sent a message of draw. You can only send a message if it can accept a message. It means that draw should have a method draw. Only then you can send a draw message to the circle. Same is the case here. So rectangle object has been created, and then rectangle draw method is called, or rectangle object has been sent a draw message. And same is the case for square. Square draw method is called. Now let's see here the sequence diagram in relation to. First of all, main method is in the specification. You can see that these are 4 lifelines: sequence demo, circle diagram demo, rectangle, and square. Then main method is called in the sequence diagram demo class, and as a result of calling executing main method, first of all New draw means object of circle is being created. Then message draw is sent to the circle object. Then a new rectangle object is being created, and then draw method message is being sent to rectangle. Similarly, new square object is being created, and then draw message is being sent to the square method. So same is the code here. You can relate that this is circular draw. Here it is draw message is being sent to the circle. And here is we are creating new circle object. Here new circle object is being created. So this sequence diagram is has been generated automatically in this tool. So let's see. Let me give you a demo of this tool. Okay, so let's see. This is Skype. This is sorry Eclipse, latest version of Eclipse 2020 of 3rd March of March. And here you can see I have created a project which has a circle class, rectangle class, then shape class, square class. So here you can see the code of first of all shape. So this is an interface shape, public abstract void draw. Then square is implementing shape and implementation of square. Then implement rectangle, implementation of rectangle, where implementation of circle, and then implementation of main method in sequence diagram memo, where you can see that this is very same that I have discussed in the slide. Now, if I want to, once I will install this tool, then I have to right click in the package where I want to create the editor, others, where I write object. You can see object create class diagram. Here I am selecting it, and then I give it some name. Shapes 2, for example, I will give name shapes 2, finish. We find there is a blank editor available. Now I will select the required classes which I want to draw. Let me remove few one. This one. And I'm dragging it over here, and here you can see that it has been so here you can see the shape interface and then 3 rectangle boxes. This is how you can create a class diagram. It is reverse engineered from the code. Similarly, if I want to create a sequence diagram, then I have to add some lessons that you will get for 1 month. But how, first of all, you have to create an editor. Here you can see that there is the object get sequence diagram editor. We give it some name, shapes, 3 for example, I'm writing. Now I am dragging this class, sequence demo class over here. So you can see that a lifeline has been created. Now this has a class has a main method. I'll drag it over here and I'll leave it on the main method. So here you can see main method was drawn because it is part of this class. So I have brought it over here, main method. Now I'm selecting the text of main method and clicking, right clicking, and I'm add called operation, writing add called operation. So you can see all the method calls which are part of main method. And this is life of the main method. This black rectangle is showing the life of main method, how long this main method is going to execute. So first it calls new circle, then draw new rectangle, draw new circle, draw. So this is how a sequence diagram is generated with this tool, which is known as object aid diagram. Okay, coming back to the presentation. This is what I have demonstrated you. Now let's move forward. Okay, there is another tool known as Jive. This tool is again an excellent tool for analyzing the Java code, and this tool also has you can see the reference given above. You can download this tool, and you can also experiment and create sequence diagram with the help of this tool. Now I'll give you a demo of this tool. Okay, now after installing Jive, first of all, I will open Jive's perspective. You will see here my mouse, Jive perspective, and here I'll click it, and you will find that Jive perspective has been opened. After that, I will go to the debug menu, debug configuration, and then in debug configuration, you find after installation, there is a Jive tab here. Here I will check enable debugging with Jive. Here you can see I enable debugging with Jive, and then I can close it down. Now this is main method. I have to debug this main method. Okay, so I'm going to right click override, and I have to create basically debug debug configuration. Here you will see Java application with Java debug configuration. From here you have to open it, so that we have to run basically this main method. So here enable debugging in Java is already visible to you. I'm clicking with debug, and it's saving some unsaved items. So you can see it has stopped in debug mode. I have placed a breakpoint over here. So it has stopped in the first line where it has to create the circle object. So here you can see a top level object class is being shown. It has environment variables. Classes are being used. These are not for the user. It is being done something internally. But here you can see a main method call has been sent. So main method has been executed. So this is a call for main method. This is a life. This is the timeline. So at the moment it is stopped over here after creation, after call to main method. Now I'll execute. For example, let me see step over. So it has gone to circle.draw. So here you can see in the sequence demo, main method has called the created a circle object. This is symbol for object. Let me move forward. Step over. So you can see that now it is here. You can see once object of circle is created here. Below is the sequence diagram. Circle lifeline has been created over here, and this circle object message is sent creation method. Then a draw message has been sent. Here you can see the draw message has been sent. Now it has to execute this line. It means that what should happen? A rectangle object should be created. Okay, let's see. Step over. So as you can see, a rectangular object has been created. Here, a rectangle left line has been created. Now it has to execute draw method of rectangle. Step over, and the draw method of on rectangle has been message has been sent. Now move forward. Now it has to create a square object. A square object has been created from main method. Here you can see, and here you can also see a lifeline. And now draw message to square has to be sent. And this draw message has been sent. So now it is exiting. So it has exited. So you can see that complete sequence diagram has been created. Now this upper object diagram is showing that three objects have been created. Here complete sequence diagram has been generated. So it's a wonderful tool for analyzing Java code. At the end of this lecture, I've given you a reference of a video, YouTube video as well. You can see that video as well. Now, coming back to the lecture. Slides. So this the snapshot which I have given demo is placed over here in the lecture slide. Now, coming on to some nitty-gritties of sequence diagram. These boxes are called combined fragments, and there are various kinds of combined fragments. For example, this box is showing that these activities are to be done up to 3 times, minimum 1 and maximum 3 times. This activity, this sequence is to be followed in a loop, and minimum 1 time, maximum 3 times. So if this combined fragment is not there, you can see that you have to draw it 3 times, and it will be very bad method for modeling it. So it provides some elegance in modeling the loops. Then OPT, it means option. It means that if loop is invalid, if loop is not valid, if the password is not valid, then the option is that password may be valid. So if password is valid, then this is PAR. PAR means parallel. It means that it will come in the option if password is valid, then this option will be availed instead of this option. So it is giving some sort of decision, some sort of if-else statement, that when the password is valid, then this command fragment has to be used. Within that command fragment, there is another command fragment with the name of parallel. It is indicating that enter message and enter amount, enter account and enter amount, both messages will execute in parallel. So this is the concept of combined fragment. These are various types of combined fragments: alternatives, options, loop, parallel, strict sequencing, sequence, weak sequencing, critical region, assert, manipulation. So this is a link. In this link, you will find all the you will find examples of various these combined fragments. Let me show you if I have opened the that okay. Picking up then let me place it over here. So okay, and let me show you that you'll find example of each for your understanding. It's taking some time. Okay, so this is the page combined fragment, and you can see these are different options which I have listed over here. You see that it is explaining each option along with the example. Option, loop, break, parallel, strict sequencing, weak sequencing, critical region, ignore, consider, election, negative, and that's all. So please go through these examples. You will get the idea what does it mean. Okay, so now let's move forward. Here you can see I have made some changes in the code. In the square, in the square, once I have after creating the square object, I have written the square dot draw in for loop. It has to execute for 4 times. It has to execute 4 times. Square dot draw has to execute it 4 times. So you can see once I have generated its sequence diagram, then a combined fragment has automatically been generated in the sequence loop for I less than 4 draw dot byte. It means that it has to execute for I less than 4 from 0 to I less than 4. Okay, now you should also have some idea that Visual Studio 2012 Ultimate also has a facility of generating a sequence diagram. So here I have written C sharp equivalent code of the same example, and let me give you demo for this as well. Here you can see the program in the studio. Here it is the same main method. It is C sharp equivalent code. Here you can see interface has been created, circle class, rectangle class, square class, and this is the implementation of main method. Now, if I have to create the sequence diagram, I'll right click on over here, and you can see here generate sequence diagram. Keep in mind that this feature is only available in Ultimate Visual 2012 Ultimate. So here you can see program, circle, rectangle, square, and you can also see a combined fragment, because in the program I have made that I have developed it. Similarly, you can also draw the class diagram as well. For example, this is main program. If you want to see the class diagram, you may right click over here on the project and see class diagram. So you see that three circle, square, and rectangle classes with shape implementing shape interface. And this the shape interface with method draw is being done. So VStudio is supporting, Ultimate is supporting the class diagram generation as well as sequence diagram generation. So let's move forward. Interaction views. So interaction views. Let's see the new concept. Interaction views is an interaction fragment which allows to use or call another interaction allows to use another interaction. It means that if, for example, here you can see it is a checkout interaction, it has been modeled somewhere else separately, but now you are referring it over here. Not, it is being shown as a black box. At a moment, you don't know what is inside, how it has been modeled, but it is being used over here. So there are two lifelines, web customer and online bookshop, and it has been developed somewhere else, and it is being referred here. Its name is checkout. Large and complex sequence diagram could be simplified with interaction uses. It is also common to reuse some interaction between several other interactions. Let's see. So this is the homework for interaction diagrams. Download Eclipse latest with JDK 8. This is download link. Install Object8's class sequence diagram plugin. See how class diagram can be generated from Java code. This is a link. Then install Jive on Eclipse and experiment with it. And here is a Jive demo on YouTube. And use C# equivalent code to generate sequence diagram in Visual Studio. So whatever demo I have given you, try to run that demo. Coming on to interaction overview diagram. Interaction overview diagrams provide overview of the flow of control where nodes of the flow are interactions or interaction uses. So it means that I'll give you the example. Then we will understand what I mean by interaction or interaction uses in the next slide. Interaction overview diagram do look like activity diagram that can only have inline interactions and interaction uses instead of invocation actions. So generally in active diagram, you'll find actions which are connected together through control flows. But here, instead of actions, you'll see inline interactions and interaction uses. Thirdly, UML interaction overview diagram combines elements from activity and interaction diagrams. So this is an interaction use which I have shown you in the previous slide. Let's see the next example. This is an example of interaction overview diagram. Here you can see the activity symbol, initial node, activity initial node, and here it is activity final node. And there are various control flows which you can see over here. First of all, From initial node one, once we come here, we come across an interaction views. That is a reference. It means that this interaction has been developed somewhere else and we are just referring it over here. Here you can see an inline interaction. So once control comes here, then this interaction starts, and then once this interaction stops, then control comes here and then move forward. So here it is an interaction use, this is an interaction use, and you can also see some sort of time duration constraint is also being applied here. So this is how an interaction overview diagram looks like. Now coming on to communication diagram. Communication diagram was called collaboration diagram in UML 1.x. That is, for example, UML 1.5 was one of the version. It used to be called as collaboration diagram, but now it is called communication diagram. It is an interaction diagram which shows interaction between objects and parts representing as lifeline using sequence messages in a free-form arrangement. Communication diagram corresponds to a simple sequence diagram. It means that communication diagram and sequence diagram, these are interchangeable. You can convert a communication diagram to sequence diagram, and you can convert a sequence diagram to communication diagram. Let's see, first of all, example of communication diagram. There are three objects. First of all, we create objects. If it would have been a sequence diagram, then these would have been three lifelines: A lifeline, B lifeline, C lifeline. But here, these are three objects, and these objects, object A is sending message raw to object B, and object B is sending message to paid message to object C. So this is 1.2. It means this message will be sent first. 1.3, this message will be sent later on. Here you can see parallel, it is 2.3a and 2.3b. So it means that two parallel messages are being sent, one to B, one to C from A. Let's see another example. Interaction online bookshop. First of all, it is one. So an actor is sending a find book message to online bookstore. Then 1.1, it is one search message is been sent to inventory. Then 1.0, view book message is been sent to book. Then 1.3, message is been sent to here. And then 2.1, again first of all 2. Then this is one flow. Then second 2 message is coming here. Then 2.1 this message. Then 2.2 second message and 2.3 second message. So you can easily transform a communication diagram into a sequence diagram. Let's see a transformation example. Here you can see the above communication diagram, above sequence diagram. This is sequence diagram and this is communication diagram. It's old name written here, collaboration diagram, but it is communication diagram. Now it is called communication diagram. So here you can see, first of all, a create message has been sent to transaction. Here you can see at number 1, create message is sent to transaction. Then second message is this one, set action. Here you can see set action is at number 2. Then this is the third message, destroy. But here these messages are coming as 2.1, set action, then 2.1, set value message being sent to ODBC proxy, then 2.2 message, set value message being sent to here, and then the third message destroy is being sent to the transaction from this diagram. So it is an example of same concept depicted in sequence diagram as well as in communication diagram. Coming on to the timing diagram. Timing diagrams are UML interaction diagrams used to show interactions when primary purpose of diagram is to reason about the time. Once you have to plan and give some idea about the time, then timing diagrams are very useful. Timing diagrams focus on conditions changing within and among lifelines along a linear time scale. Let's see the example. Here, timing diagram example, stages of Alzheimer's disease. So if you can see, as you are moving towards the right on x-axis, there is a time, and on y-axis there are different categories. So no, we start from no impairment, then normal for forgetfulness. It may last from 2 to 7 years. Then early confusion, 2.2, around 2 years. Then mild Alzheimer. Then so timeline of every disease has been given in the timing diagram. Let's see a bit more practical example. Here you can see a timing diagram example for user experience website latency. For example, you click a URL and you want to analyze that how much time it is taking at various stages, because after clicking a URL, it has to first go to web browser, then it will go to DNS resolver, then it will go to servlet, then it will go to data access layer, then it will go to JSP layer, and then message will come back, and then it will again come back to web browser, then the result will come to the user. So every stage will take some time. Every stage has to take some time, and after analysis, you can very elegantly model the latency at different stages with the help of timing diagram. So you'll appreciate the power of this timing diagram. Okay, these are some of the references you'll find in the uploaded lecture, and it ends lecture 5. And thank you for taking time to see this lecture.